Continuing with trigonometric function modeling, on the back of the handout, we have a chart that shows us the average high and low temperatures in Seoul, South Korea over an entire year. So if you look at this chart here, it has the months on the horizontal axis, January through December, and on the y-axis, it illustrates the temperatures over time. Now, if you've been paying attention at all with graphing sine and cosine functions, hopefully you kind of get a feeling of which function this is, sine versus cosine, but if not, that's still okay. Well, just go ahead and reading into the problems here. Number one asks, what is the maximum and minimum average high temperature throughout the entire year? So if it wasn't obvious, you have two curves that are given to you. And the curve that illustrates the highs is this red curve. And on the handout, obviously it's not colored, but this red here is illustrating the highs. So to find the maximum and minimum, just look at the graph they're giving you of the data. And the maximum would be, if you notice this point here they give us, August 4th. So the maximum, I'll just say max, equals 85 degrees Fahrenheit. And the min average high would be in January 18th over here, 34 degrees. Number two asks, what is the maximum and minimum average low temperature? So that would be that blue curve below the red curve there. And let's see here. We want to find the maximum of that curve, and that would be here, 75 degrees Fahrenheit. So we'll say max is 75 degrees Fahrenheit. And the min would be the low, same place, or the same month, but on the blue curve would be 21 degrees Fahrenheit. In number three, we jump right into trying to create the function model. So in the previous video, or in the previous section we talked about, you were given a model and you're trying to make sense of the model. But now we're trying to look at the data and trying to reverse engineer the model, right, the function model. So it says you are given the partial model AFT for the average high temperature graph. Determine the missing values in the function, including if the function best models the data using sine or cosine. Your model should have a period of 12 months. Assume t equals 0 represents the month of January. Okay, well, to make some sense of this, I'm going to go ahead and show you a couple sketches that you might be familiar with. So if you had a sine graph, the sine function does something like what I've just drawn here. It starts on the midline, and it increases, then it decreases, and then it comes back to the midline, and that's one period. So this is our friend, just sine of x, let's say. What cosine does is cosine starts at the maximum, and then decreases to the minimum, and then comes back up to the maximum. So that would be like cosine of x. Something like that. It's a rough sketch. You could graph it on decimals to get a better idea. If you look at our graph once more, our graph of the data here, it starts at the minimum value, and it increases to the maximum, but then it returns back down to the minimum. So what we literally have here is the vertical reflection, or the x-axis reflection of cosine. So ours is more like this. It starts at the minimum, comes up to the maximum, then comes back down to the minimum. So that would be the x-axis reflection, which would just be negative cosine of x. So the first thing I just want to point out is, if you're curious about which function this should be, it is a cosine graph, but it is more specifically going to be the negative of the cosine graph. All right, so a couple things here. Let's just make note. We should know that this value that multiplies your, well, I'll talk specifically about the cosine, this would be your amplitude. Right, so the value that's multiplying your sine or cosine function is your amplitude, regardless of the negative. And then the k value here, that I just called k for no reason, just arbitrarily k, this is our midline value. So let's make some sense of what we're working with here. So to find the high model, let's rewrite what we know. The maximum is 85 and the minimum is 34. So the maximum is 85 and the minimum, well, what are we supposed to do with that? Well, the midline would be right in the middle of those, right? So that's kind of the definition of your midline. It's the average of your maximum and minimum. So our midline should fit right in between these. And this is the equation in terms of y, right? It's a horizontal line. So I have a calculator off to the side here. I'm just going to add 85 plus 34 and divide by 2. Okay, so this would be, I'll rewrite what I just did. I did 85 plus 34 and divide by 2, and the result should be 59.5. So our midline temperature would be 59.5 degrees. And to find the amplitude, that's the distance from your maximum to your midline or your midline to your minimum, right? So the distance between our maximum, 85, and the midline, which I'll show off here, our amplitude, I worked out by doing the following. I took the maximum value, and I subtracted the midline value. 85 minus 59.5, and I get 25.5. So to make sense of this, what's happening is we have a midline value of 59.5 degrees, and our maximum and our minimum should be the same distance from the amplitude, which would be about 25.5 degrees. So therefore, if you put this all together and made a function out of it, put all this information together to make the model, it would look something like this. A of t equals. So what I showed us earlier is it would be the vertical reflection or the x-axis reflection of the function. So it's going to be a negative amplitude value, which is 25.5. So negative 25.5 cosine of 2 pi over, and we still haven't talked about m yet, so I'm just going to put m back. And then plus the midline value, which is 59.5. So we almost have our model, except for we have to just talk about what m would represent. Just going back to before, if you remember the previous example, we looked at the period of Mars rotating around the sun. If you notice in the model, we had this strange frequency, which was 2 pi over 687. Well, if you remember in the calculation we did, what happens when you find the period is the 2 pi will cancel with the 2 pi in the frequency, and this bottom expression, the 687, actually just becomes the period of the function. Going back to our example, if I want the period to be 12 months, then that would actually be the value of m. So just to rewrite my function, a of t equals negative 25.5 cosine of 2 pi over 12 t plus 59.5. And this model should satisfy all the conditions that I've laid out. It should have the same maximum, it should have the same minimum, it should have the same midline, and it should have the same period. And I would leave it for you to just go ahead and check with Desmos if you want to graph it, just to kind of see that it kind of shows off the same features as the graph they showed us of the temperature data. Now, it won't fit perfectly, but that's why we call it a model. It does its best to fit. And of course, if you were in a higher level mathematics course, you might be able to get a more precise model. But for our needs, a simple sine and cosine graph is very close to what we're looking for here. Just to repeat, this function we came up with models the data pretty well.